All right, in this module, I'd like to talk specifically about pyroclastic material and pyroclastic rocks and how to name them and a little bit of the terminology. We've looked at these terms before: aphanitic, porphyritic, for textual terms for volcanic rocks, products of lava flows. And I mentioned the last time that pyroclastic material are those materials like ash, fragments of rock, or lava fragments that are erupted from a volcano, and that pyroclastic rocks are comprised of pieces of those pyroclastic materials when they're lithified, and to give the textural term fragmental to pyroclastic rocks. Now, I want to explain some of that in more detail. Here's some pyroclastic material. Ash is very fine pieces of volcanic rock. Lapilli that are more pea-sized or gravel-sized particles of volcanic rock, or bombs that are actually molten or semi-molten volcanic material that's ejected from a volcano, and it gets kind of a streamlined look to it as it's crystallizing, as it's flying through the air. This table lists different kinds of volcanic products, but I want you to focus on the airfall fragments. And this pyroclastic material is classified only on size. So we use the terms, I don't use dust, I just call everything that's 2 millimeters or less ash. If it's between 2 and 64 millimeters across, you can call that a cinder. I prefer the term lapilli, so I'll include that here. This is also lapilli. Or if it's a larger piece of volcanic material, more than 64 millimeters, it's either called a block or a bomb. And the only difference is if it's ejected as a solid, already solidified piece of volcanic material, it's a block. If it's molten or semi-molten when it's ejected and it's been plastically deformed, it's called a bomb. So that pyroclastic material is the material that's coming out of a volcano, and this is Mount Pinatubo in the Philippines, with a large ash cloud being ejected into the atmosphere. And that is full of ash. And there are also smaller particles like small particles like lapilli, blocks, and bombs that are coming out during eruptions like this. The ash travels farther than the heavier material, the larger particles that fall nearer to the volcano. Some of this material might be coming out in pyroclastic flows or mud flows or lahars. These examples here are pyroclastic flows. So these are avalanches of this pyroclastic material, and includes gases, ash, pieces of rock, actually anything that gets in the way of the pyroclastic cloud as it's moving down, sometimes 500 kilometers an hour and very, very hot. The bombs, the blocks, these larger particles, they can be very sizable. Those aren't going to travel very far. Those are going to drop down near the volcano. This is a cinder cone in Argentina, and I'm looking at the cone of the cinder cone, and you see that there are blocks and bombs dotting the surface of the cinder cone. And then in the next image, I'll turn away and face the other direction, and you see very distinctly that the blocks and bombs end at some point, and what is beyond that zone is the lighter, smaller particle material like lapilli and ash that falls from an eruption. Now, if those materials, that is the ash, lapilli, blocks, and bombs even, are deposited and then become lithified at some later point, cemented together or lithified, you're going to end up with a pyroclastic rock. It's comprised of just those particles of pyroclastic material. And the pyroclastic rocks could have individual crystals. There's a small crystal of what looks like a hornblende or maybe a pyroxene, or there might be particles of actual rock that could be lapilli or blocks or bombs if this is larger. And how you name pyroclastic rocks depends on the composition of those particles in it. So we use these classification diagrams. Start over here with this diagram where you're deciding if the rock has ash-sized particles, lapilli-sized particles, or blocks and bombs in it. And then depending on the proportion, again with the corners representing 100% of any of these materials, depending on the proportion of those three materials, that is what is going to help you to name the rock. And all of those rocks that I have in our lab are, fall into the lapilli tuff or the tuff category. And as I said, you start here and to name a rock. If you end up with a tuff, you actually go one step further and use the second diagram to classify the kind of tuff that you have. And that's based on whether you have glass particles, rock fragments, or crystals, mineral crystals in the tuff. And then again, depending on the proportion of those materials, you might have a vitric, a lithic, or a crystal tuff. So what you learned in this module is that pyroclastic material is classified by the particle size only, that pyroclastic rocks are comprised of pyroclastic material, so the rocks that are lithified from different pieces of those individual pyroclastic material, and that pyroclastic rocks are named based on the proportions of the pyroclastic material in them. Now, this is as far as I'm going to go with pyroclastic rocks or pyroclastic material in this class. I will cover more on pyroclastic rocks in volcanology in the fall.